Now write down third inversion when we will fix the link 3. So third inversion, first application, write down oscillating engine, oscillating cylinder engine. In this, cylinder will be oscillating, okay? Oscillating cylinder engine. Here it will be found when we fix link 3. When we fix link 3, okay? So draw its diagram. Its diagram will be like this. Let's say this is the link to crank, okay? This is the link 1, then 2, and 2 was connected with the connecting rod. So this will be our third link. So this time third link is fixed. Initially first was fixed. So first was your cylinder, yes or no? In first case, standard mechanism, first was your cylinder. So this whole body is single. This whole body is single body. It will be like cylinder like this. So this whole is link 1. Okay. This whole is link 1. Now, link 4 was your piston. So I am drawing piston here like this. Piston here like this. And it is also single link. These are not two links, okay? Single link this is. And it is hinged here. It is hinged here. Let's say like this. आपको पूरा फील देने के लिए बहुत कुछ करना पड़ता है। अभी ठीक। Okay. So now when you will rotate this second link, okay, then this fourth link will be going inside outside the cylinder, and both these will be reciprocate about this hinge. Yes or no? It will be continuously rotating. It will be reciprocating like this. Can you feel it? Okay. So actually it was like this. But fourth link and first link we can interchange because same relation will be there of sliding. So now the simple modification is done. Simple modification is done. Fourth को they will make the cylinder. Fourth को they will make the cylinder. They will exchange 4 and 1. Fourth they will make the cylinder, and first they will make the piston like this. But the relationship and the type of motion, type of pair, everything will remain same. Okay. Now this cylinder can be hinged here simply like this. Yes or no? Or I can make one more external thing like this. Now clear? So when this will be rotating, this will go inside outside, and this cylinder will be oscillating here. So just interchanging the link 4 and 1 like this, cylinder and piston, you are interchanging. Okay. So here this oscillating cylinder will be obtained. Simple. Clear or not? So these type of modification we can do. These are allowed. Clear? So your third link is fixed. Now, next of third inversion, that is slotted lever type quick return mechanism. ये बना दिया सभी ने? Good. Slotted lever quick return mechanism. थर्ड का B. Quick return mechanism. This is also the third inversion. तो फिक्स लिंक कौन सा होगा? फिक्स लिंक 3. थर्ड लिंक ही फिक्स होगा इसमें. इसका थोड़ा डायग्राम जो है दैट इज इजी. देखो कैसे बनेगा. पहले सर्कल बना लेते हैं. लेट्स ड्रॉ ए सर्कल लाइक दिस. इन दिस सर्कल here okay 2 3. So this was your crank. This was your crank, second link. Then connecting rod, third. So this time this connecting rod is fixed. Connecting rod is fixed. Okay. And third is connected with the 4. And 4 and 1 are exchanged here. 4 and 1 are exchanged here. 1 is this made the piston. 1 is made like piston. And fourth is made like slotted lever. So actually the photo of slotted lever is what? Slotted lever will look like this. Slotted means there must be a slot inside that. Slotted means उसके अंदर एक slot will be cut down. So a slot, cutted slot must be there. Actually this is called slotted lever. This will be called slotted lever. A slot is cut down in that like this. Okay, this is the lever. So when slot is cutted down in that, inside that this piston or slider can be there. Now this slider will be here and it can slide inside this. This can slide inside this. Like this. Okay, so it can slide inside that. So actually this is slider and this is slotted lever mechanism. So actual picture is this, but nobody draw like this properly. Okay. This hole is a single body like this और उसके अंदर एक slot कटा हुआ है. Slot is cutted inside the lever. So actually slotted lever is this. Okay, this one. This lever is like this and this piston or slider is like this. Figure is clear? So when it will be moving, this crank will be continuously moving like this. So this lever will be oscillating about this center. Oscillating about this center. And it will be at farthest position. It will be at farthest position when the angle between them will be 90. So it will be at farthest position, let's say here, when the angle between them will be 90. Yes or no? एंगल बिटवीन देम विल बी 90। ऐसे बना देते हैं। This is. So right now it is at farthest left position. Okay. Now mechanism is completed. What are the external part? External part, again one more bar or lever you can apply here, and there will be a tool. There will be a tool like this, cutting tool. Okay. So cutting tool will be moving here. Right now it is at farthest left position. Let's say this crank is rotating like this. So now it will start the motion. So when it will go from here to here, the tool will move from here to here. This will be the stroke of tool. Stroke. Okay. So for the going, this will be the angle, forward angle. Okay. And this will be return angle. So forward angle, again we will consider beta more than alpha. So alpha is small, this is the return angle, beta is the cutting angle or forward angle. And this link is rotating with constant omega, so it will take more time for beta, less time for alpha, more time for forward and less time for return. That's why its name is quick return mechanism. Clear हुआ? तो इसको बना दो. So what we will draw here, फिगर को थोड़ा एडजस्ट कर लिया जाए. Actual slotted lever is this. Now I am drawing this will be your angle beta, cutting angle. Alpha will be your return angle. And this link 2 is rotating here with constant omega. Constant omega like this. Okay. So here what will be the quick return ratio once again? Quick return ratio. So if quick return ratio is given in the problem more than 1, then what you will write? More than 1 means beta by alpha you will write. So beta will be nothing but 360 minus alpha divided by alpha. Okay. So it will be more than 1. And if in question quick return ratio is given to you less than 1, then you will apply the formula what? Alpha by beta. Alpha by beta like this. Then it will be alpha upon 360 minus alpha. Okay. This. So this is how you will apply the formula. Clear? जिसको क्लियर हो गया जय हिंद लिख दो फटाफट. So this was the inversion number 3rd का B. Very good. Now 4th inversion of this mechanism. 4th inversion of this mechanism. तो इसमें भी आपका एक पार्ट है 4th का A, इसमें सेकंड पार्ट नहीं है. इसमें लिखो 4th का A, हैंड पंप मैकेनिज्म. हैंड पंप मैकेनिज्म. ठीक है. तो इसमें एक ही है, सेकंड नहीं है इसमें. तो इसमें कौन सा लिंक फिक्स करेंगे बेटा? फिक्स लिंक 4. ठीक है. लिंक 4 को हमको फिक्स करना है यहाँ पर. अब लिंक 4 को फिक्स करना है. हमारा स्टैंडर्ड क्या था? 1 2 3 4. सो लेट्स से दिस इज 1. ओके. लेट्स से दिस इज 1. 1 से कनेक्ट था आपका 2. ठीक है. 2 से कनेक्ट था आपका 3. 3 के बाद वो कनेक्टेड था 4 से, ठीक है। तो मैं क्या कर रहा हूँ इसमें, देखो मॉडिफिकेशन, 3 को यहाँ कनेक्ट कर देता हूँ इस तरीके से। नाउ दीज आर मॉडिफिकेशन पार्ट, मॉडिफिकेशन कैन बी देयर लाइक दिस। सेकेंड को और एक्सटेंड किया, सेकेंड को और एक्सटेंड किया लाइक दिस। थर्ड को यहाँ के बजाय, या अभी बना रहने दो, अभी दिस फर्स्ट विल बी अवर सिलेंडर, this will be whole same body, first is our cylinder, so first right now is this, second is this, third is this, fourth is this. अभी फिगर ड्रॉ मत करना, I am doing modifications, okay. Now what modification is done, इसमें जो ये फोर्थ है, fourth they will make the cylinder and first they will make the piston. So this first they will draw like this, modification they will do, this will become your first, this will become your first, okay. Now with this first they will connect the second, second is connected like this, second is connected like this, and fourth they will make the cylinder, fourth they will make the cylinder. So here after modification this whole link is single link, okay, this whole is single link. So this is now link 1, link 1, and here little modification in the cylinder, they will make a hand pump like this, okay. So here this fourth one will be fixed, here this fourth one will be fixed, and modification in 3, it will be connected here like this. This is extended part of 2, this is extended part of 4. तो बन गया भैया अपना क्या, हैंड पंप। क्लियर है कि नहीं? सो नाउ यू विल मूव दिस लिंक, सो व्हेन इट विल गो डाउन फर्स्ट लिंक विल गो अप, सो वाटर विल बी कमिंग लाइक दिस, हैंड पंप बन गया आफ्टर फ्यू मॉडिफिकेशंस। तो अभी नेमिंग अच्छे से कर देता हूं मैं। दिस इज योर फर्स्ट लिंक, नाउ this is second, this is third, and this is fourth. Clear? So this is hand pump mechanism. Whether you keep this fix or move this, or you keep this fix, move this whole cylinder pipe, in both cases water will come out. Whether you move piston inside the cylinder or you move cylinder inside over the piston, in both cases output will be same, okay. That's why we can interchange. So moving this whole cylinder is hard, and a whole pipe of the hand pump will be very heavy, so that you will make fix and interchange with the first, so that only first will be moving like this, fourth will be fix, and output will be same. Got the point or not? है ना? So after few modification this is done. और इसमें भी क्या ले लेते हैं, मैकेनिकल एडवांटेज, दिस लेंथ विल बी लेस, दिस लेंथ विल बी मोर. When you apply here less force, okay, so about this hinge, F2 into L2 torque will be more due to this length, and here length is less, so force will be more, so more force F1 will be here to pull it upward. So here mechanical advantage is also there. Getting point or not? So mechanical advantage about this hinge, let's say this hinge name is A or O, A or O, A मान लेता हूं मैं. So mechanical advantage about O, A लिख दिया. So here let's say you are applying here force F1 and this length is L1 this side, this length is L2 this side. Okay, and F1 into L1 will be here torque like this. So same torque will be on this side and I am considering, इसको देखो थोड़ा अप्लाई करने के लिए करना क्या पड़ेगा, इसको हमें पहले इससे 90 करना पड़ेगा, हेयर 90, सो दैट टोटल फोर्स F1 विल बी यूज्ड हेयर, क्योंकि ऑल टाइम दिस एंगल विल नॉट बी सेम, बट एट द टॉप पोजीशन व्हेन दिस लिंक विल बी हेयर ना, like this, horizontal, perfectly horizontal. In that case this F1 into L1 will be equal to F2 into L2. Okay, so for that case only I am writing F1 into L1 equal to F2 into L2. Okay, so F1 will be equal to L2 by L1 into F2, like this. So F1 will be greater than F2. Yes or no? Greater than F2. So F2 is input, F1 is output. उल्टा लिख दिया क्या मैंने? F1 is F1 L1, F2 L2, what's wrong, F1 into L1, F2 L2, so F1 will be L2 by L1 F2, correct. F1, if F1 is the input, then F2 will be output. F2 होगा ना output, yes, F2 will be our output, not F1. F2 is the output, so F2 will be equal to F1 L1 by L2, so F2 will be more than the F1, yes or no, because your L1 is more. Okay, so here mechanical advantage will be what? Force output over force input. Force output is F2, force input is F1. क्लियर हुई बात? बना दो अब. तो इधर मैंने F1 लगाया, here it will be F2, perpendicular. This is extra thing, this is not so much required, don't worry. I'm just giving you the simplest example of mechanical advantage. Hand pump में this distance will be kept less, this distance will be more. So this is the simplest example of the mechanical advantage. Okay. सर कंफ्यूज हो गया यहाँ मोमेंट में, F1 L1 इक्वल टू F2 L2 है. F2 L2 y. अभी बताता हूँ किस किस को ये समझ पड़ गया, पहले ये बताओ. हाउ मेनी ऑफ यू आर क्लियर विद दिस? दिस इज एक्स्ट्रा थिंग नॉट रिक्वायर्ड here, but being a mechanical engineer you have to idea of it, you have to have idea of it. Those who are cleared with this, write down Jai Hind. Those who are clear with this, write down Jai Hind. This term L1 by L2 will be more than 1 ना बेटा, कौन पूछ रहा था? COMPTRACK 25. L1 is more, L2 is less, so this term will be more than 1, so F2 will be more than F1. अब आपको इसका ब्रह्म ज्ञान चाहिए तो वो तो मैकेनिक्स से मिलता है। एफबीडी बनाना पड़ेगा, ये लीवर है, ये इधर हिंज है, इधर F1 लगाया आपने। मैंने कहा इसको जब हॉरिजॉन्टल पोजीशन में रखोगे तब के लिए है ये। राइट नाउ दीज फोर्सेस आर नॉट, सो ओनली फॉर दैट पोजीशन आई एम टेलिंग यू। तो इधर F1 लगाया, इधर L1 है, तो ये ऐसे मूवमेंट मिलेगा इसको टॉर्क, यस और नो? सो दिस एंड विल ट्राई टू गो अप। इससे क्या कनेक्टेड है तुम्हारा? ये कनेक्टेड है, दिस इज कनेक्टेड, सो this will be pulled upward by F2 force. Equal and opposite F2 will be acting here. This is L2. So when balancing condition is there, just about to move, so when you will balance the movement here, so F1 into L1 will be clockwise here, and F2 into L2 will be anti-clockwise here. क्लियर हो गई कहानी? और भी कोई समस्या है? सारा रहस्य मैकेनिक्स में छुपा है। दैट्स वाई आई टोल्ड यू, मैकेनिक्स को सभी लोग अच्छे से करो, आराम आराम से करो। सो यहां आप लेस फोर्स यू विल अप्लाई, मोर फोर्स विल बी रिक्वायर्ड टू पुल द पिस्टन अपवर्ड। हाँ, एवरीवन क्लियर नाउ? बोलो बोलो। सो सिंपलेस्ट एग्जांपल ऑफ द mechanical advantage, by applying less force you can pull heavy weight। ठीक है, क्यूआर का एक से नाम आना क्या बताता है? क्विक रिटर्न रेशियो। क्विक रिटर्न मतलब इट विल रिटर्न बैक फास्ट। Forward stroke will be slow, but return stroke will be fast. Okay, so generally quick return ratio means it should be taken less than 1. ये जल्दी वापस आ रहा है, बट इन दी बुक्स, इन दी क्वेश्चंस, हम लोग भी क्वेश्चन करेंगे, वी विल डू गेट क्वेश्चंस आल्सो, डोंट वरी। इन दैट यू विल सी इन few question they will ask you quick return ratio, or sometime they will give you the value of quick return ratio more than 1 in the question, and they will ask the angle alpha and beta. ओके, तो हमें ये देखना है हमको अल्फा वाई बीटा लगाना है या बीटा वाई अल्फा लगाना है। इसको अपने दिमाग में रटना नहीं है कि इट इज ऑलवेज अल्फा वाई बीटा और बीटा वाई अल्फा। डोंट मग अप, सी द डेटा, सी वेदर दे आर टॉकिंग अबाउट मोर देन 1 और लेस देन 1। क्लियर हुई बात? हाँ हाँ, वो तो है ही है। इन फर्स्ट ईयर, इन फर्स्ट सेम, पीपल यूज टू टेक mechanics lightly, then they will suffer for whole 4 year of the BTech. Mechanical and civil both people. In civil also, everywhere FBD is required. Their toughest subject are like structure and all that. So structures are simply like theory of machine but in static condition. उधर तो motion भी नहीं है। We do is more complicated study than the civil people. We have to study all these things, acceleration, inertia, all these things, but everything comes out from the mechanics only. Clear हुई बात? So remove these forces from here, otherwise you will get again confused. Just here both these torque or movement both side balanced, then this equation is there. Now everyone is clear. Okay, good. So these 4 were the inversions of slider crank mechanism. 4 inversion were there for 4-bar mechanism and 4 inversion were there for slider crank mechanism. Okay, now we are going to do inversions of the double slider crank mechanism. Inversions of the double slider crank mechanism. Okay, चलिए तो उसको स्टार्ट करते हैं. At last, at the end of the chapter, we will cover all the questions. Don't worry.